Hi students. Now I'm just trying to compare an embedded system with a general purpose computer. Maybe to compare the various layers of these computers to understand a little better. Let us compare embedded system and the general purpose computer. I have put up this general purpose computer represented by 5 different layers shown here. A hardware, firmware, device driver, operating system, and application. Okay, what is hardware? I think we all know. Hardware, okay, we say anything which is physical in your computer is hardware. Essentially, okay, we have various devices like mouse, keyboard, monitor. In the CPU, we have motherboard, RAM, many things like that. This is what is hardware. Probably put a summary of that. Okay, probably you will come to know that hardware is nothing but few I/O devices. I/O devices like, okay, as I said, okay, keyboard, monitor, mouse, like that. Then we have a CPU, processor is there. Then we have some memory, ROM, RAM, memory. Some peripherals also would be there. Put together is what is hardware. Remember, we were okay. First time when we started understanding a computer, we put a block diagram. The block diagram was CPU connected with input unit, output unit, memory, and that's what, okay, the block diagram of a computer. Essentially, we represented the hardware of it actually. Okay. Yes, that's hardware. Such hardwares are loaded with a firmware. Okay, a firmware. A firmware is a low-level software which is essentially required to activate every hardware or to instruct every hardware. This firmware is loaded into the hardware. Firmware is referred as low-level software because it very closely interacts with hardware to get every hardware task done successfully. For your kind information, these firmwares may be developed by the hardware engineer because he knows the hardware better than a software engineer. Usually the firmwares are written by hardware engineer, somebody who has got the complete idea about the hardware functions can only write the firmware. To make you understand this firmware better, probably I would give an example. Let me take a known device like hard disk as an example. So we all know, okay, hard disk. Hard disk is a steel plate coated with ferric oxide, mounted on a spindle motor. That's what is, okay, hard disk. And the disk has been mounted with some head actually. Okay. Yes. And disk touches certain portion of your this particular media, and we call it as track. That's why the data could be written and read. Yeah, I think we all know this construction. Now, I'm just taking a user, okay, operation. And user is performing an operation. The operation is he is copying a file from one folder to other folder. Okay, what this means for hard disk, I'm just assuming, like it may be transferring data from 50th track to 150th track. Transferring data from 50th track to 150th track. Maybe, assume. Or then, wherever the head is, we need to bring it to the 50th track. I need to bring it to the 50th track. And read the complete track information. Load into some buffer. Yeah, buffer is there. Okay, there is some memory. Okay, in this hard disk. Okay, available. So dump it there, and then move the head towards 250th track, and dump this buffer, which was backed up earlier, into the track. Operation completed. The file got moved from one folder to other folder. Fine. I'm just analyzing. The head need to be moved from 50th track to 150th track. Now, who moves the head? Yeah, closely observe. There is a stepper motor, okay, which is used, okay, which is connected to the head. Yeah, which essentially moves the head. Oh, fine. To move the head from 50th track to 250th track, then how many steps need to be attained by this stepper motor? And to make a particular step, one step, how many pulses need to be given to this stepper motor? And what is the sequence of that pulse? What is the polarity of these pulses? Yeah, don't worry. Okay, it's been already programmed. You just need to provide the source and the destination track. It will automatically transfer himself from 50th to 250th. Yeah, there is some firmware which is existing here. Okay, yeah, hard disk is not only this steel plate, this media. Also, we have a hard disk, okay, control unit here. Okay, yes, that's an example of a firmware. Similarly, every system possesses, okay, this firmware. Every hardware is loaded with firmware. In fact, commercially speaking, this firmware and hardware together is what is referred as hardware. Okay, that's what is referred as hardware usually. When you buy, okay, a hardware for your general purpose computer such as, okay, PC, let's say you buy a mouse firmware is already been burnt there. Keyboard firmware is there. Monitor firmware is there. So every hardware is been already loaded with firmware. Firmware is a low-level software loaded on the hardware to perform certain very critical hardware tasks. Okay, now I have a hardware. I want to connect to my system. My system is already a functional system. It's been loaded with some OS, operating system is there. Let's say I have Windows there. Okay, I have Windows. Okay, fine, it's a Windows computer. I want to connect a hardware. Let's take a hard disk itself. I'm just connecting, okay, a new hard disk to the computer, and then, okay, booting up the operating system. Just check what's happening there. Then you'll come to know that nothing happens. Because the new hardware which is plugged in to the computer is not recognized by the operating system. Obviously, because it's a new hardware, it doesn't recognize it. Okay, I'm just, okay, telling you that operating system does not recognize any new hardware connected. In fact, there is no operating system which can understand any hardware. Similarly, there is no hardware which can understand any operating system. No, there is no hardware which is pre-built with some firmware to understand an operating system. No. Obviously, because okay, both are developed by two different vendors. They do not have any kind of understanding between. Oh, it becomes essential that we need to connect operating system and the hardware. Operating system and the hardware need to be interfaced. A piece of code that we write to interface the operating system and the hardware is what is this device driver. Device driver essentially is to ensure the hardware becomes functional under an operating system. Basically, this device driver works as an interpreter. You know, it interprets operating system commands to hardware, OS commands. Similarly, it also interprets uh, the signals which are generated from the hardware to operating system signals. Okay. Yes, that's what is device driver. Yes, this device driver is essential, without which we cannot make an hardware work under an operating system. Yes. Every device, every hardware which need to be recognized by an operating system and used by the operating system, it has to be supported by this device driver. Yes, I'm able to work with keyboard today because keyboard device driver is loaded. Mouse device driver is loaded. Screen device driver. Motherboard device driver. USB device driver, like that. Anyway, that's device driver. The next layer is operating system. I think we all know a little bit about operating system. It's a collection of software which is used to manage the various resources of the computer. Yeah, we do have a lot of hardware resources. We have software resources. Somebody who need to manage all these resources together to get it used optimally is what is referred as operating system. He is a system manager. This operating system is a system manager. Fine. Also provides UI, user interface, maybe CUI, GUI, to ensure the user can interact with the system. Anyway, that's operating system on which we have loaded application. Anyway, application is the key. Application is the key of the entire system because we did develop the entire system for what? To run this application only. Application is the key of any system. Okay, application is user defined. Okay, fine. That's a general purpose computer, the various layers of them. Now I'm trying to compare this with an embedded system. In embedded system, we have only two layers: hardware loaded with application. Oh yeah, hardware loaded with application. Yes. We need some firmware to make some hardware functional. Okay, then you will write firmware, make it a part of your application. Firmware becomes a part of your application. Yes. It doesn't exist isolated or as a separate entity. It has to be a part of your application. Okay. Your system may be a complex system having many resources, a lot of software and hardware resources. Then we cannot manage them manually. Then we go for operating system. Oh yeah, you want operating system? Yeah. Get the kernel of the source code of the OS. Yeah, integrate with application. Means this OS kernel source code should be a part of your application. Yes. Then once operating system comes in, then we need device driver so that this OS can recognize the hardware. Yeah, write device drivers. Make that a part of application. So it is application integrated with operating system, device driver, firmware made as one image. We call this as image are one program and loaded on the hardware. Yes, that's how it is. See, if you are an application programmer, software engineer, assume you are a Java programmer, then where are you working? If you see, hey, you are working here, you develop applications for the existing system. As an embedded programmer, as an embedded developer, hey, we work here. Okay, we work here. We need to develop application. We are the one who need to customize operating system. We have to develop device driver. We also have to develop firmware. Yeah, the blend of application, operating system, device driver, firmware is loaded to hardware. Yes, that becomes okay our responsibility. Yeah, in fact, okay, an embedded developer should be a very good application programmer and a very intelligent system programmer. Yes. Yeah, this so happens that okay, you may have to develop all these things. Assume you join some considerably a larger organization. If you join some tiny organizations, then probably he may ask you to develop hardware also. Yeah, you guys are electronic engineers, can develop, he may understand. Also ask you to develop hardware. Yeah, which means we become responsible for end-to-end development, the complete system development. Yes. In fact, that makes embedded engineering or embedded system development to be very interesting. Yes. If any of your classmates or your seniors working in the industry as a software engineer, maybe like Java programmer, ask him, okay, what is he doing? What kind of work that he is doing? Yeah, definitely he will explain you what is he doing. You will never understand it because he himself doesn't understand the complete project. He knows only about an assignment given by the project manager. But coming to embedded development, until and unless we know the complete architecture of the system, we can never write a piece of code here. Yeah, which gives a complete knowledge about the system. We develop the system. We don't develop only an application software. We develop the complete system. Fine. Yeah, as a embedded programmer, we become accountable for developing application, operating system, device driver, firmware, sometimes hardware also. Yes, this is comparing a general purpose computer with an embedded system. Thank you very much for listening to me.